So, in this new world of AI-powered testing, what's the one skill that's becoming more critical than ever? It's not really about writing code faster. It's about thinking smarter. In this explainer, we're diving into algorithmic thinking, which is really the key to making AI a true partner in building scalable and reliable test automation.
Okay, let's just get right to it. This is the question on everyone's mind in test engineering, right? As AI gets better and better at all these tasks, is it going to make our core skills, well, obsolete?
And the answer? Well, it isn't just a simple yes. It is a resounding yes. See, in this new era, human logic isn't just relevant, it's actually becoming the most critical piece of the entire puzzle.
To really understand why, we've got to be on the same page about what we're talking about. We're in an era of AI-Augmented Test Automation, and the key word here, the one to focus on, is augment. This is all about using AI to enhance and amplify our own abilities, not to just replace them. The best way to think about this is to see AI as your co-pilot. You're still the pilot in the captain's chair, setting the destination, making all the critical decisions. The AI is your invaluable partner, handling the instruments, running checklists, and managing all those routine tasks so you can focus on navigating the really complex stuff ahead. So, this is the big takeaway right here. It's all about a fundamental mindset shift. Forget replacement, think amplification. AI takes the repetitive, time-consuming grunt work and just accelerates it, freeing you up to focus on the good stuff, strategy, design, and complex problem-solving. And here's what that amplification actually looks like in practice. Your AI copilot? It can generate boilerplate test code in seconds. It can automatically fix broken selectors after a UI change. It can even analyze tons of historical data to tell you, hey, these are the most critical tests to run right now. Okay, so if AI is handling all those routine tasks, what does that mean for you? Well, your role evolves. And this is where you get your new superpower, the skill that truly sets you apart. And that's algorithmic thinking. This is the real engine that will drive reliable and scalable test automation from now on. So what do we actually mean by algorithmic thinking? It's simply the ability to break down a really complex testing problem into a series of formal logical steps. It's not just about writing a script that clicks a few buttons. It's about designing a deterministic system that knows how to make decisions under all sorts of different conditions. And I think this slide just nails the evolution perfectly. We're moving away from the world of static scripts that just, play back recorded steps. Instead, we're engineering intelligent workflows. These are systems that can actually think, adapt, and execute based on the logic that we design into them. All right, enough with the theory. Let's get practical. How does this look in your day-to-day work? Let's dig into these specific tools from computer science that you can apply directly to your test automation today. First up, dependency graphs. You might hear the fancy term directed acyclic graphs, or DAGs. The idea is simple. Instead of running tests randomly, you model the relationships between them. For instance, this test needs user data, so it must run after the user creation test. It's just common sense, formalized. Now, the payoff here is huge, and it's immediate. By modeling these dependencies, you get intelligent test ordering, and even more importantly, you get safe parallelization. The system now knows which tests can run at the same time without tripping over each other, which can dramatically speed up your CI pipeline. Okay, next tool in our toolkit is combinatorial testing. Just imagine you're testing a feature with a bunch of configuration options, different browsers, operating systems, user roles. You get the picture. Trying to test every single combination would be an absolute nightmare. That's where algorithms like pairwise testing come in. And the benefit is just massive. Instead of that brute force approach with thousands of tests, you create a much smaller, super high-impact set of tests that covers all the pairs of interactions. It is a classic example of algorithmic thinking, getting maximum risk coverage with minimum effort. Okay, so beyond data structures, we have design patterns. Think of these as reusable, structured solutions to the common problems we all face. They're absolutely essential for making any test suite, especially one with AI-generated parts, reliable and easy to maintain. Let's start with the pattern for reliability. We've all been there, right? A test fails because the network was a little slow or a UI element took an extra second to pop up. Instead of a fixed wait, exponential backoff increases the delay with each retry. So you wait 1 second, then 2, then 4. You get it.
This is incredibly powerful for building resilience right into your tests. It makes them robust against that temporary system flakiness, whether it's in the UI, a microservice, or just a little network hiccup. You get fewer false alarms, and people start trusting the automation again. Now, for those really complex user journeys, like an e-commerce checkout flow or an authentication process, you can model the application's behavior as a state machine. A user starts in a logged out state. They transition to logging in, then to logged in, and maybe eventually to a session expired state. By explicitly defining the states and the valid ways to move between them, you make your test logic completely deterministic. It becomes so much easier to understand, to debug, and to maintain. It's a structured approach that's just perfect for validating those complex flows. Okay, so let's take a step back and pull all these threads together. We've got our AI copilot handling the execution tasks, and we've got you, the human engineer, applying algorithmic thinking through these powerful data structures and design patterns. So what does this new dynamic actually look like? There's a single quote that I think perfectly captures this entire idea, and it's this: AI writes test steps, you build test systems. The AI can generate a line of code, sure, but you are the architect. You design the entire quality system where those steps live and operate. And this slide lays out that partnership beautifully. On one side, AI excels at raw execution, at self-healing, at generation and analysis. Your role? Your role is to provide the strategy, the logic, the design, and most importantly, the context of why any of these tests even matter. AI provides the speed, you provide the purpose. And that leaves us with a final thought to mull over. The tools we have are giving us unprecedented power to automate faster and more comprehensively than ever. So the ultimate question isn't about the tool anymore. It's about how you, the engineer, will apply your structured, algorithmic intelligence to wield that power effectively.